Hey guys, welcome to my custom scene for Unity shader tutorials. The objective of these is to make you excited for next semester's intermediate computer graphics and to see the value in actually learning this stuff because I've only been doing this for like a year and a half, and I feel like I've created a bunch of cool stuff that I'll be able to share with you guys as we do things. Today, we're going to be learning how we can make this, and the reason why it's cool and yeah, sure, you can just make a C# script and do this, is because there is no C# script. This doesn't use anything to do with the CPU. It's entirely GPU rendered. And you don't need a collectible script. I only have this because I have special types of coins in my game that I need to mark as different stuff. You could just handle everything through layer checks, and you can make it static, so you can bake it into your scenes. This is as optimized gets for stuff like a coin. You can also chuck this into a particle system and have it in a beautiful little particle system. So that being said, if this doesn't interest you, you can just leave, like it's cool. But if it does, you can download the collectibles, these items, from the canvas, and you can download a URP project if you don't already have one, because that's what I'm working in. You can probably do this in HDRP as well, definitely not SRP. And yeah, my current version is 2022.3. The 0.4 should not matter. And let's do it. So what we're going to do is we're going to first create a folder called INFR 1350, which I've already done. That's the name of our course. And then we're going to create a C#, not a C# script, but a shader graph URP lit shader. Now a lit shader is a shader that can receive shadows and make shadows. So we're going to call it move and rotate. You can call it whatever you want. Oh, and also Rain, I'm sorry for using your models, but deal with it. Rain's a student in this course. You guys should say hi to him and make him feel awkward about me using his models. He's in my group. Love the guy. Anyways, so what we're going to do is we're going to right-click on our shader graph, and we're going to create a material. And let's call this coin mat. And we're going to do it again. Create material, and this is going to be gem mat. You don't have to do both. You can only do one if you want. And then just apply it to, your object. And you can actually see now what I'm talking about. They're not actually moving. So let's open move and rotate. Yeah, let's open this up. And then generally when you're working in shader graph, you want to be able to see the scene, so what you're working with. And you want to have up here your update settings, turn them all on. And then let's hide the AI navigation. We don't want that. Let's shrink this down. Cool, so we have a little window. Now there's a bunch of cool things we can do. We're not going to look at the fragment today. That's going to be in the next one, where we're going to make a custom color picker. So you'll be able to change the colors of things. And what we're going to do in the next one is we're going to be able to draw on our coin, which is going to be pretty cool. The vertex shader is the vertices of an object. If you're doing modeling, then that's something that should be pretty evident to you, and it's something that we're going to talk about a lot later. However, a transformation matrix is why these things are called transforms, because they contain positions, rotations, and scales. Now in here we don't have position, rotation, and scale, we have position, normal, and tangent. But with the right knowledge and manipulation, you can achieve all of the exact same results. You can make an object grow, shrink, rotate, bob, whatever you want it to do, and it's so cheeky. Eventually you'll learn about stuff like billboards, and it's all using the same shenanigans. So what we're going to do, the first thing we need is a position node. The position node we're going to change to object space. So what this means is it's our object's position in their local space. If we don't do object space, then it's going to be in some weird world space anchor, and it's going to rotate around the world instead of itself, which is going to look strange. So position space, and then let's just get it to bob up and down, which is super easy to do. We're going to create a time node, and then what we're going to do is create a vector 3 that's called move axis, and it's going to be the direction it moves. Okay, let's give it a default value of 1. Then we're going to create a float that's going to be called speed. What we're going to do is we're going to multiply the time by the speed, Or let's actually rename the speed. Let's call it move speed. It's more accurate. Move speed. There you go. We're going to multiply our move speed by our time. And then we're going to multiply this again with our move axis. And then we are going to add this to our position. Okay, and if you give move speed a default value, for example 2, you should see nothing really looks like it's happening. If you plug this into position now, and we save the asset, I'm silly. Sorry, the reason why this isn't working is because it's going off into infinity, because we forgot a sine node. So after you multiply, plug it back into a sine, and then plug it back into the multiply, and there we go, that looks more appropriate. Yes, okay, and then we save the asset. Here we go. Weird. Oh, I accidentally changed the object position space. There we go. So yeah, again, make sure you're in the right object space, and then we have our material. So we can change one of them, so that way they're different, and you can see that when you increase the speed, they bob faster. Yes, and if you increase the axis, it'll go higher, which you may or may not want. But if you're doing something like a Minecraft item effect, what you'll probably do is you'll decrease this, and then you'll increase this to like 5. It's been a long time since I played Minecraft, but you know, something along those lines. Maybe it's in like water or something. That is literally what you do. Now, we want it to rotate. But there's a bit of a problem. And the problem is that it might look okay, but that's until we apply materials. So I know I said that we weren't really going to talk about fragment, but we're going to come back to this. With fragment, we can just plug things in to give it nice colors. And again, if you're doing modeling animations, it should be pretty clear to you. So we're going to do one for color, we're going to do a float for metallic, we're going to do another float for smoothness, which is just the opposite of roughness if you're used to Blender. And you just plug things in, metallic to metallic, and smoothness to smoothness. Now it's cool here, and emission is glowing if you want it to glow, by the way, which we'll do next time. Metallic, metallic and smoothness, what you want to do is you want to press on mode, default, slider. And this is going to prevent you from making mistakes. And smoothness to default, slider. Let me save it. And then it goes black because the color by default is black. So on the coin material, let's pick a color. Let's do like a gold. Maybe like this. And then let's increase the metallic and the smoothness. And there we go. Now, I was saying something about normals, and there's probably going to be an awkward cut in the video, but I was just wrong. So I'm sorry if there's a weird cut in the video. But with this shader, and I've also done the gem as well, we have our coin and our gem, and they're bobbing up and down, and they are responding to light. If you look at the gem the right way, you can see how it's interacting with the light and angles, which is great. So now what we want to do is we want to rotate it. So we're going to say rotate, about axis. Okay. Then we are going to plug in the output from here as our input. We're going to create a vector 3 called rotation axis. Plug it into our axis, and it's going to have a default of 1 on the y because it's going to rotate around the y, just like it would in 2D space. And then our rotation is going to be in degrees by float, degrees per second. Okay, and then we're going to multiply our degrees per second by our time, and then pass this finally through our rotation axis. Just like that. That's nicer. Okay, and then we plug in this output into our position. So by default, our degrees per second is 0, which we probably should have increased. So let's put this just to 100. And now it's looking pretty weird. Why is it doing this? That's because we're never rotating the normals. So the solution is really quite simple. All we need to do is take our normal vector. Here we go. Make sure we're in object mode on our normal vector as well. Can hide this multiply. And then let's take another rotate about axis. We're going to rotate our normals about the axis, like literally exactly the same, just our normals instead, and then plug this into the normals. And there we go. And like, it's this easy when you understand what you're doing to make cool optimized shaders. Now, as I mentioned earlier, you can make everything static, but there is an exception to this. If you turn on batching static, here's what's going to happen. You can make multiple of an object like this. You can make multiple, but when you press play, you're going to get kind of a weird effect, and this boggled me for a little bit. There they go. So they're automatically going to start rotating around the center axis. And if that happens, and it's happening to you, and you're like, what's going on? Just turn off batching static. That's it. And now it'll be fine. And you can put these all over your game. You are free to use them. Have fun, buddy. There they are. Looking good. So in the next one, we're going to draw our custom images onto the coins, and they're going to look pretty sick. Yeah, that's it. I'll see you next time, and have fun.